Hey everybody, we're going to jump into solving equations here. This is something that you do pretty much every year in your high school life and probably a couple years before that. 6th, 7th grade, a lot of times you get started on solving equations. So let's go back to the most basic kind of equation that I can think of, the one-step equation. And you're going to notice a pattern here. Solving equations is all about inverse operations. Whatever's there, you have to do the opposite to get rid of something. So for instance, x plus 7 equals 11. If you want to know what x is, you need to get rid of that 7. And the best way to get rid of adding 7 is to subtract 7. Poof, there you go. You make sure you do it to both sides, and you find out that 11 minus 7 is 4. X equals 4. Some teachers teach it with a line going through the equal sign just to make sure you can tell the difference between the two sides and that you never get the left and the right confused. And that's okay. I'm just kind of going with the most basic explanation here because these are the most basic types of equations. Alright, next one. X minus 3 equals 5. Well, how do you undo subtracting 3? Well, how about we add 3? So we're going to add 3 to both sides. 5 plus 3 is 8. Hey, what do you know? X equals 8. Now the next problem, 5x equals 30. In this case, the 5 is being multiplied by the x. So how do you undo multiplying by 5? Well, how about we divide by 5? So you divide both sides by 5, and you end up getting x equals 6. Because, well, after all, 5 goes into 30 6 times. Alright, the last example here, x divided by 8 is 10. How do you get rid of dividing by 8? Well, you multiply by 8. Just make sure you do it to both sides. Not just the left, but also the right. And you find out that x equals 10 times 8, which is 80. Alright, now let's get to the next type of problem. Now we're talking about two-step equations. They're not as basic, but they're still not scary because as soon as you're done with the first step, suddenly now you're back to another one-step equation. So let's look at 2x plus 6 equals 14. Well, that plus 6 is getting in the way. I don't really like the way it looks, so let's get rid of it. There you go. Take away 6 from both sides. Now that plus 6 is going to go away. 6 minus 6 is 0. 2x is the only thing left on the left side, and 14 minus 6 is 8. Now it officially turns into a one-step problem. Divide both sides by 2. Multiplication and division are inverse operations. If you want to get rid of multiplying by 2, divide by 2. You find out that x equals 4. Now this next example is the exact same way. To get rid of subtracting 3, let's add 3. And that's going to give us 5x equals 22. Now you've got a 5 in front of the x. Let's get rid of it. The way to undo multiplying by 5 is to divide by 5. And that gives you, wait a second, 5 doesn't go into 22. Okay. Now, you might have teachers that tell you to turn that into a decimal. You might have teachers that tell you to turn it into a mixed number. But what I have found, especially at the higher levels of math, is that most teachers just want you to leave it like that. X equals 22 over 5, and that's it. That looks good to me. If a student gave me that answer, I would be totally fine with it. All right, let's take a look at the last one here. 1/3 is in front of the x. Then we're adding 15, and that equals 22. Well, first of all, that 15, we could get rid of that. Now, I'm going to show you another way of handling this later on, but this is one way of doing it. Just take 15 away from both sides. That gives you 1/3 x equals 7. Now, I know it doesn't look exactly the same, but this is just like the example above it. 1/3 x, 1/3 times x, is the same thing as x over 3. It's the exact same thing, which means I want you to think of that 3 on the bottom as sort of a division situation. This is really 1 divided by 3. And how do you get rid of dividing by 3? Well, you multiply by 3. And as long as you do it to both sides, you're good to go. The 3's on the left will cancel each other out. 3 times 1/3 is just 1, which means x equals 7 times 3, which is 21. All right, let's go down to the next section here. Now we're talking about what happens when you have a whole bunch of steps, 3 or more. All right, for these problems, you've got a little extra work to do. I would probably do all of these problems in 3 steps. You could maybe say the last one takes 4 steps. It depends on how you look at it. If you look at this next problem, 5x minus 17 equals 2x plus 4. You know, order doesn't really matter in how you accomplish the first couple of steps. You just need to make sure that you've got variables on one side and numbers on the other. So if we take care of the variables first, we could take 2x away from both sides. And what that would do, that would take the variables away from the right, and it would leave us with variables on the left. Everything else you could just bring down, and there you go. 3x minus 17 equals 4. I think that's the easiest way to do it because now your problem has turned into a 2-step problem, just like the ones we practiced. You add 17 to both sides. That gets rid of the negative 17 on the left. That gives you 3x equals 21. Divide both sides by 3. 3 goes into 21 7 times. I think that's the easiest way to approach that problem. You might have done it differently and gotten the same answer. That's perfectly fine with me. Now, here's where the debate starts. Some teachers say you always need to move your variables to the left side. Some teachers don't really care where you move them. I'm one of that second group. I don't really care where you move them. Now, is it better to move it to the left side when possible? Maybe when we're dealing with inequalities or things like that later. Yeah, it might be a little bit less confusing. But mathematically speaking, you're allowed to do whatever you want. In this case, I'm going to give you an example of moving things to the right. Let's move the variables to the right. That means that 3y over there, I don't want it. I need to get rid of it. I'm going to take it away. I'm going to take away 3y from both sides. That will leave me with a negative 5 on the left. 8y minus 3y is 5y, so I've got a 5y on the right, and the negative 15 just comes down. Now, if we're going to put our variables on the right side, that means we need to move our numbers to the left side. So we are going to add 15 to both sides. That way our numbers are on the left and our variables are on the right. Negative 5 plus 15 is 10. 10 equals 5y. Well, now to get y by itself, all we have to do is divide both sides by 5. 5 goes into 10 twice. All right, this last example over here, I tried to throw people off. Maybe it wasn't that confusing. I don't know. But the biggest key here is we need to combine our like terms first. We have a 2x and a 5x on the left side. They are both on the left side. So in this case, if we add them, if we combine our like terms, we don't have to bring the other side into it. We can just do it. We can just say 2x plus 5x is 7x. Everything else can stay the same. We weren't trying to use inverse operations or anything fancy like that. We were just trying to combine like terms. Same thing on the right. That 3 plus 6, I don't like the way it's written. I'm going to call it 9. I didn't have to do anything fancy. I didn't have to move things around or subtract from both sides or anything like that. I just did it. 3 plus 6 is 9, so I just did it. From there, you can add 5 to both sides, just like the usual 2-step equation. And if you do that, you end up getting 7x equals 14. And you probably know that 7 goes into 14 twice. So sure enough, x equals 2. All right, let's get to these problems with distributing. We are going to work on distributing a little bit. And the first example, we pretty much have to distribute. There aren't a lot of good options other than distributing, so we're going to do that right now. We are going to distribute the left side and the right side. So 6x minus 12 equals 2x plus 12. All right, next, let's get the x's to the left. Now, you could do something with the 12s right off the bat if you wanted to. I'm going to take care of the variables first, and then I'm going to take care of the numbers. So I'm going to take 2x away from both sides, and that's going to give me 4x minus 12 equals 12. At this point, a lot of rookies think the 12s are going to cancel out. Nope, because if we add 12 to both sides, that'll get rid of the 12, the negative 12 on the left. The right side now has 12 plus 12. So what we're actually going to have here is 4x equals 24. And so if we divide both sides by 4, I might have enough room to sneak this into the corner. X equals 6. Now, let's get to the details about distributing. I wrote this next example twice because I wanted to make sure you understood that you are always allowed to distribute, but it's not always the best option. Now, I'm going to go through this problem 2 different ways, and I don't know which one you're going to like more. But what I will say is one of them involves 3 steps, one of them involves 2. So I think the 2-step option is the best option just because, well, I'm lazy. I don't know. I want to get through the problem faster. So let's try it with distributing first. Let's distribute. 4 times x is 4x. 4 times 1 is 4. That would be step 1. Now you take away 4 from both sides. 4x equals 20. Then if 4x equals 20, you divide both sides by 4 to get your final answer. X equals 5. Now that was really fast, but we could actually do it faster. Because we could, instead of distributing the 4, we could divide off the 4 first. And that gets rid of it completely. You don't even have to distribute. Dividing by 4 takes that 4 in front away. All you have left now is x plus 1 equals 6. Take 1 away from both sides, x equals 5. So you get the same answer anyway. So that's another way of looking at it. I don't know which one is better for you, but just pick one and go with it. All right, the last thing that I was going to go through today is the fraction trick. And I don't know if you would necessarily call it a trick. I do. You can call it whatever you want. But basically, here's what I'm talking about. Do you absolutely hate fractions? Do you hate dealing with any problem that has fractions in them? Well, then get rid of them. Get rid of the fractions. Those fractions there in this example have a 2 in the denominator. So that 9 is really 9 divided by 2. And that 3 over 2, that means 3 divided by 2. So if I don't want the fractions, I could just multiply everything by 2. And that seems like it wouldn't really be allowed, but as long as you do it to both sides, so not just the left side, but the right side as well, as long as you do it to both sides, it's okay. That's how inverse operations work. As long as we do something fairly to both sides, it comes out okay. Now you can distribute the 2. That gives you 4x on the left, and then minus, hey, would you look at that? The 2 in front cancels with the 2 on bottom, so that 9 is left alone. And it works out exactly the same on the right side. That 2 underneath the 3 is being canceled out. 2 divided by 2 is 1. It cancels out, so the only thing left is 3x plus, distribute one more time, at the very end, 2 times 3 is 6. All of a sudden, you've got this problem that doesn't have fractions in it at all, which is much better. In fact, this one turns into a 2-step problem. It looks like it's going to be a 3-step problem, but as soon as you take 3x away from both sides, you find out that really now we just have x minus 9 equals 6. Then you just add 9 to both sides to get rid of that negative 9 right there. Negative 9 plus 9 cancels out. 6 plus 9 is 15, so you've got your last answer, x equals 15. Now, if you try that type of problem and you have different denominators, you just choose to multiply by the least common denominator, whatever that happens to be. If you have a 2 and a 3 down there, multiply everything by 6. It'll cancel out the fractions. If you have a 3 and a 4, multiply by 12. So it works no matter what you do. All right, thanks for listening. Hope to see you come back another time.